We have been in section 4.5 for a while, learning what the derivative has to tell us about the shape of a graph. And today we're going to try to put it all together and graph some functions. And here's the procedure that I'm going to use that I want you to use in this section's homework whenever you're graphing a function. We're going to find the intervals of increasing and decreasing, and then we'll find all local extrema doing that first derivative test from the sign chart, find the intervals of concavity and inflection points, and then we're going to put all of those things together and try to draw a good graph of the function. So here's our first function. We're going to try to draw a good graph of this. And we're going to start off by doing step one, which is to find the intervals of increasing and decreasing. So step one, increasing, decreasing. All right, so we know that we need to take the first derivative and make a sign chart. So I'm going to take f prime of x. So this one's going to be 3x squared, and then plus 6x minus 9, derivative of 4 is 0. And we're going to look for where this is equal to 0. That's never going to be undefined. And everything here is divisible by 3. So I'm going to divide both sides by 3, just so it's a little easier to solve. And I get x squared plus 2x minus 3 equals 0. So I'm going to factor this to solve it. If you want to use the quadratic formula, feel free to do so. And let's see. I need a 3 and a 1 to give me the 3 on the end, and I need the 3 to be positive and the 1 to be negative. That gives me negative 3 on the end, and then the inner and outer terms combine to give me plus 2x. So I'm going to set both of those equal to 0. I've got x minus 1 equals 0, x plus 3 equals 0. Add 1 to both sides over here, subtract 3 from both sides over here, and I got my two numbers that I need for my sign chart. So let's draw our sign chart. And let's see, I'm going to mark -3 and +1. And we're going to make statements about f prime of x on top and then f of x on bottom. Remember, this is going to give us increasing and decreasing information. So I'm going to find f prime of a number on the left-hand side. So let's pick something over here. Let's do f prime of -4. Something in between -3 and 1 would be 0. Again, pick any number you feel like. I'm just trying to pick the easiest ones here. And I'll pick f prime of 2 over here. So we're going to take our derivative and find f prime. So f prime of -4, f prime of 0, and f prime of 2. So let's see what we get for these three derivative values. All right, so that gave me something positive in this region, negative in the middle region, and positive in the right-hand region. So again, we're making statements about f of x. This is the first derivative, so this is going to tell us increasing and decreasing. So we're increasing, and then we're decreasing in the middle, increasing on the end. All right, so let's just kind of summarize that down here. We're going to say f of x is increasing on -∞ to -3, and from 1 to infinity, decreasing on -3 to 1. So I'm going to head over to my axes where I'm eventually going to graph this and sort of store this information on that page. Here's my final answer graph paper, and I'm going to store information as I find it. So we found that we were increasing from -∞ to +3. So I'm going to go over and mark -3 on my graph. And I'm going to draw myself a little line through -3 to kind of break this up. This is not part of my final answer. I'm just going to use this to store some information. So I know that I am increasing over here, and then I'm going to draw myself another line at a tick mark of 1. So let me draw myself a vertical line. And again, I'm going to erase this. This is not part of the graph. I'm just helping myself to remember. So I know I'm decreasing in this region here. And then afterwards, I'm increasing. So I'm going to put increasing over here. All right, so let's go back to that sign chart and figure out where the maximums and minimums for this function are. All right, so we're going to use the first derivative test to identify our local extrema. We know because the function went from increasing to decreasing at -3, we must have a local maximum at x equals -3. So we're going to have a local max at x equals -3. And I'm also going to find the y coordinate that belongs to that. So we're going to find f of -3 So our local max is at -3, 31. And because we went from decreasing to increasing when we got to +1, we know we're going to have a local minimum there. So we're going to have a local min at +1, comma, f of +1. So let's find f of +1. And I got a y coordinate of -1. So we're going to have a local min at 1, comma, -1. Let's go store that information on our graph. All right, so I'm going to plot some points, -3, 31. Obviously, I don't want to make these y tick marks as big as I made my x tick marks. Otherwise, I'm going to be way off my page. So I'm going to count my tick marks by 5 on the y-axis so I can get up past 31. So we'll say 5, 10, 15, 20, 25, 30, 35. And just mark a couple of them so I know what your scale is when you're graphing. So I'm going to plot my local maximum at -3, 31. So -3, 31 is going to be a little bit above that 30 tick mark. So we'll keep that on my final graph. And then I also want one at 1, -1. That's going to be very close to the x-axis. I have to keep the same scale on the y-axis down here. So that has to be -5. So 1, -1, our local minimum is going to be super close to the x-axis. The next thing we need to do is find our intervals of concavity and our inflection points. So let's find our second derivative, f double prime of x. It's going to be 6x plus 6. And we want to set that equal to 0 to find our possible inflection point. So subtract 6 from both sides and divide by 6. That's going to give me x equals -1. So then we're going to make our sign chart. This time we're going to do it for f double prime of x. And then we'll make concavity statements about f of x below. So we need to put x equals -1 on our number line. And we're going to test the second derivative on both sides of that. So we're going to find f double prime of, let's say, -2. And something to the right of -1 would be 0. Love plugging in 0. So let's find f double prime. Here's our second derivative. F double prime of -2 and f double prime of 0. So I got -6 on the left-hand interval, so that's negative. And then I got a positive number for f double prime of 0. So that means concavity again. Negative means concave down like a frown. Positive concavity means concave up like a cup. All right, so let's write this information down. F of x is concave down on -infinity to -1 and concave up on -1 to infinity. So let's go put this on our final answer graph. All right, so there's our concavity information. Everything's happening at -1. So I'm going to put -1 on here. And I'm going to mark another line, another vertical line on my graph that I'm eventually going to erase here at -1. And I know that before that line, the function has to be concave down, and after that line, it has to be concave up. All right, so let's go figure out where our inflection point is, and then we'll be able to draw the graph. So we know we changed concavity at -1. And up until now, I've always just kind of labeled this and I say we've got an inflection point at x equals -1, which is true, but I actually want to put the inflection point on the graph. So we need to find its y coordinate. All right, so our official inflection point is at -1, comma, let's find f of -1. So go back to the original function and we'll find f of -1. So our y coordinate at our inflection point is 15. So I'm going to put -1, comma 15, and we'll go add this to our graph. All right, so here we are, and we have our inflection point at -1, comma 15. So let's go ahead, -1, comma 5, 10, 15 is right there. So I'm going to plot my point, and I know that's where we're going to change concavity. So now we want to go fill in the graph. Now, keep in mind that this was a polynomial, and we've seen tons of polynomials over our mathematical career. We know these are roller coaster graphs. They're wavy, they're continuous. So we want to kind of keep that in mind as we fill this in. All right, so I'm going to start off on the left-hand side of this graph. It's increasing and it's headed up towards that maximum at -3, 31. It's increasing and it's concave down. So we want this to look like the increasing concave down part of a parabola. So we're going to have an increasing concave down looking graph as we come up. We're increasing towards that maximum. And once I hit that green line, I know I need to start decreasing, but I'm still concave down. So we're going to decrease in a concave down kind of way. That's going to look like the other side of a parabola. So decreasing and concave down. Once I hit my inflection point there at the pink line, that's where I need to start changing to a concave up, but I'm still decreasing. So I want to look like the decreasing concave up part of a parabola. So I'm going to be decreasing, but concave up. And I keep doing that until I get to my local min. And now that's where I'm going to change to increasing, but still concave up. So increasing and concave up looks like this. And blessedly on homework, we can always go take a look at Desmos and see if we got the right graph, but this looks pretty good to me. The last thing I really want to do is to get rid of all these vertical lines that are cluttering it up that are not actually part of the graph. So I'm going to erase all of these lines. And there's my final graph.